Welcome to the Deep Dive. Today, we're jumping into a topic that comes up a lot in the materials you've shared with us.
Yeah.
Efficiency.
Right.
It's something that, well, it really touches everything, doesn't it? From your daily habits to, the appliances sitting right there in your kitchen.
Absolutely.
We've got a stack of sources here,
Yeah.
and they break it down in a way that seems super clear, really relatable, perfect if you're looking for a solid starting point.
It's true. We hear efficiency all the time, but what does it really mean? Especially when we're talking about, say, energy or machines.
Yeah.
So our plan is to unpack these sources you've given us, build a good foundation, and focus on, practical examples. Stuff that makes sense even if you're new to this.
Exactly. That's the mission today.
Yeah.
Make this concept totally crystal clear, no matter your background. Think of it as a shortcut to understanding something useful.
Something that helps you make better choices, maybe.
For sure. Whether you're buying a new washing machine or just, trying to manage your time better. Okay, let's get into it.
Yeah.
So the basics first, right? That's where the sources start. Efficiency, at its heart, is a ratio. It compares what you put in versus what you get out. Think about studying. You put in a little time, get amazing grades.
High efficiency studying.
Exactly. Or at work, less time, huge output, high work efficiency. It's just getting the most bang for your buck, basically.
That's a great way to think about it. Maximizing the useful outcome compared to whatever you invested.
Right, the useful bit.
And what's really interesting and comes through in these sources is how this one idea applies everywhere. Personal productivity, sure, but also deep inside our electrical gadgets.
Yeah, speaking of electrical gadgets, the sources really zero in on efficiency being a key term there. In electricity,
Definitely.
it's also defined as the ratio of energy output to energy input for electrical stuff. So a specific version of that input-output idea.
Yeah. And if you've ever, looked closely at your fridge or your washing machine, you might have seen that sticker. So something like energy consumption efficiency grade.
Yeah. I know the
That's
idea.
a perfect real-world example from the materials. This system, like the one they use in Korea that's mentioned, it gives a grade, usually 1 to 5.
There are lots of common things, right? Fridges, TVs, washing machines.
Yeah, vacuum cleaners, air conditioners, about 29 items in that specific system. It's designed to be super easy for you to understand quickly, at a glance.
And here's the really useful part for you, listening right now. Get this. The closer that grade is to 1, the better. More energy efficient.
Right. Grade 1 is the top.
And the difference isn't small. A grade 1 product, according to these sources, can use maybe 30, even 40% less energy than a grade 5 one doing the same job.
That's significant savings over time.
Totally. So if you're comparing two things, similar features, similar price, aiming closer to grade 1 seems like a no-brainer for your electricity bill.
Which does raise a good question, though. Why is there such a big difference?
Right.
What makes a grade 5 appliance gobble up so much more energy than a grade 1?
And it comes down to how much energy is just lost, wasted inside the machine.
Exactly.
Which brings us back to input and output, maybe a bit more technically. The sources explain it like this. For any machine, efficiency is the ratio of the work done to the energy supplied. So say a machine gets 100 units of energy poured in, but it only does 70 units of the job you want it to do.
Then its efficiency is 0.7 or 70%.
Right. The other 30 units, that's loss. Gone.
Yeah. So energy efficiency really is the ratio of the usable energy, the stuff that does the actual work, compared to the total energy you put in.
The sources use a fan. There's a really good, simple example. Takes electrical energy in, right? Turns it into rotational energy.
Right.
Makes wind.
Makes sense.
Now, if that fan got 100 units of electricity and magically turned all of it into 100 units of rotation,
Yeah.
well, that'd be 100% efficient.
Which never really happens in the real world, does it?
See, more likely, maybe it only puts out, say, 30 units of useful rotation. The rest is lost somewhere. So its efficiency is only 30%.
Okay, let me try another analogy, kind of like the sources suggest with the salary idea.
Okay.
Imagine your monthly pay is, say, 2,000 units. That's your input.
Right.
And you manage to save 500 units. That's your useful output, the savings.
Got it.
Your savings rate, your financial efficiency, you could say, is 25%. It's kind of like that with machines. There's always input. There's always some useful output.
Yeah.
And the difference.
That's the loss.
That's the loss.
Yeah.
Simple as that, really.
So for our electrical devices, the equation is pretty straightforward then. Useful output equals total input energy minus whatever got lost.
Yep.
And efficiency is just that useful output divided by the total input. So high efficiency just means
low loss.
Exactly. And that's why engineers, the people designing this stuff, spend so much time trying to figure out how to cut down that loss.
Makes sense.
Because less loss means higher efficiency,
Right.
which means a better energy grade sticker and a more attractive product for us consumers. It's a big deal competitively.
Huge.
But where does the loss actually go in something like that fan?
Ah, good question. It doesn't just vanish.
Right. So the fan gets electricity. Not all of it makes the blade spin. The sources mention resistance loss in the copper wires.
Yeah, just the electricity flowing through metal creates heat, like friction almost. That's energy escaping.
Okay. And what else?
Well, there's loss in the iron core. That's the heart of the motor, helps make the magnetic fields.
So just making the electromagnets work costs some energy.
It does, yeah. Those are called iron losses sometimes.
Wow. Okay, and there's more.
Oh, yeah. There's bearing loss, literally friction from the parts spinning.
Makes sense. Things rubbing together.
And even wind loss. The blades themselves pushing through the air creates drag. That takes energy.
I never thought about all those little things adding up.
But you can feel it, can't you? Touch a motor that's been running?
It's warm, sometimes hot.
Right, that heat, that's tangible proof of energy loss. The fan wants all the electricity to become spinny, windy force.
Spinny, windy force. I like it.
But some just turns into heat. Or even sound, which you also don't really want from a fan. That's loss too.
Okay, so efficiency reducing loss. How do engineers actually do that? And the sources have this really, really clever analogy. The household budget.
Ah, yes, that's a great way to connect the dots, isn't it?
Totally.
Think about it. With a budget, you track your spending, right, from your income, which is usually somewhat fixed. The whole point is to spot where you're spending unnecessarily. Those are your financial losses. You analyze, find the waste, and cut it.
Okay, I see where this is going. It's the same with electrical devices.
Pretty much. Just like your budget has maybe fixed costs like rent and variable costs like going out to eat.
Right.
Electrical losses also fall into two main types, according to these materials.
What are they?
There are fixed losses, sometimes called no-load losses or iron losses.
Okay. Fixed how?
They're pretty constant. They happen mainly in that iron core we mentioned, and they're there basically whenever the device is on, regardless of how hard it's working.
Like your rent payment, always the same each month.
Exactly. It's always there. Then you have variable losses.
And these change.
Yep. Mostly copper losses that resistance heat in the wires.
Yeah.
These go up as more electricity flows as the device works harder.
Ah, like your spending on entertainment or clothes might go up or down depending on the month.
Precisely. And here's the clever part, connecting back to the budget. Smart budgeting means you focus your cuts, right?
Yeah.
You probably target those variable expenses more easily than your fixed rent.
Yeah, easier to cut back on movies than renegotiate my lease every month.
Well, engineers do something similar. They analyze which type of loss, fixed or variable, is the bigger problem or easier to reduce for a particular device under typical conditions. They target their efforts strategically.
So they might focus on using better copper to reduce variable loss, or maybe a different iron core designed to cut fixed loss, depending on the goal.
Exactly right. It's strategic optimization based on understanding where the waste is happening.
Wow. It really is like managing a budget, just with watts and volts instead of dollars and cents.
It's a surprisingly powerful parallel, isn't it? This idea that efficiency, whether it's your money, your time, or your appliances, is fundamentally about minimizing that waste, that loss.
And maximizing the useful output, getting the most out of what you put in.
Once you start seeing that pattern identifying the losses, whether it's wasted time or money down the drain or heat coming off a motor,
Yeah.
you kind of see things differently.
Yeah, you gain the power to optimize, to make things better.
Yeah.
So thinking about that parallel, managing your household budget versus designing a high-efficiency motor. What stands out most to you? It's something to really chew on.
It is.
We hope this deep dive has given you some powerful new ways to think about efficiency.
Thanks for tuning in.
Thanks for joining us.